Hi students, today we're going to talk about simplifying expressions with negative exponents. Hopefully you've already watched the video on complex fractions and you've gotten a good handle on those so that when we move to this negative exponents piece, you're just going to have to learn one new transition step and then it's basically going to just be simplifying a complex fraction. So let's dive in. So when it comes to simplifying expressions with negative exponents, really what that means is that we want to get rid of the negative exponents. Negative exponents can be translated into division, and we'd prefer to see division than to see negative exponents. Sometimes we'd rather see the negative exponents, and we want to just get comfortable with moving between fractions and negative exponents. What situation you're in, you can use whatever representation of your expression best suits your needs. So I want to just kind of remind you guys that if you have something like x squared, that 2 in the exponent just tells you how many times to multiply by the base being x. So x squared means x times x. Essentially, it means multiply by x twice. Well, when we get to negative exponents, the negative basically means the opposite. So if we have x to the negative 2, instead of multiplying by x twice, we'll divide by x twice. So to divide by x twice, that's basically like multiplying by 1 over x squared, okay? So these negative exponents mean the opposite of positive exponents. Positive exponents mean to multiply a certain number of times by that base. Negative exponents mean to divide a certain number of times by that base. So the way we translate our negative exponents is basically just to put them as a fraction under 1. Okay. All right. So positive exponents are repeated multiplication, negative exponents are repeated division. So for our first example, we're going to try to simplify this expression. 3x to the negative 1 plus x to the negative 2 times y to the negative 1 all over y to the negative 2 plus x times y to the negative 1. And I'm going to take you guys to our whiteboard where we can see what that looks like. All right, so here we are with our example expression with the negative exponents. And our goal here is to simplify this expression. And remember, simplifying means we don't want to see negative exponents because they're just really awkward. And also we have a fraction here, so you always want to simplify your fraction unless you're using it for something else. Okay. So the first step is we want to convert all our negative exponents into positive exponents. And to do that, we have to rewrite them as fractions. Okay. So this very first x to the negative 1 is going to become a 1 over x. All right. And this x to the negative 2 is going to become a 1 over x squared. And the y to the negative 1 is going to become a 1 over y. So that's how we just convert each individual negative exponent into a fraction. So our y to the negative 2 is going to become 1 over y squared. And our y to the negative 1 is going to become a 1 over y. Okay. So there in blue, I've converted every negative exponent into a fraction. Now we'll get to simplifying. And as you can see, we're going to end up with a complex fraction here. But before we even deal with our complex fractions, let's deal with the multiplication that we've just created. So we had a 3 times x to the negative 1 became a 3 times 1 over x. That's going to simplify to a 3 over x. This 1 over x squared times 1 over y, we can just multiply right across. That's going to be 1 over x squared y. And same thing in the bottom. This x times 1 over y is going to become just an x over y. So let's rewrite that. And once you get good with your negative exponents, you can probably translate right to the expression that I just drew. But until then, you might want to start with that transitional state where you do what we did in blue, which is convert everything first to the fraction, then kind of simplify each term via multiplication. Okay, but here we are, and now what we've got is a complex fraction. So we're going to decide how we want to simplify this complex fraction. We can combine the numerator into a single fraction via addition, combine the denominator into a single fraction via addition, and then treat that main fraction bar as division. So that was method 1 we learned for simplifying complex fractions. But in this case, because that's a lot of work to do that addition and then still do the division. And again, each of our denominators is just a single term with x's and y's. So it's going to be easy to find an LCD here. So I'm going to use the second method that we learned for simplifying complex fractions, and that is the LCD method. So I'm just going to take a look at all my denominators. We've got an x squared y, a y squared, and a y. So our LCD is x squared y squared. So let's just make a note of that. If our LCD is x squared y squared, then we're going to multiply our whole fraction by x squared y squared over x squared y squared. Remember, we are just working with expressions here, and we want to generate equivalent expressions. So the only tool we really have is this multiplication by 1. Okay, x squared y squared over x squared y squared is equivalent to 1. Also, remember that fraction bar is a grouping symbol. So we got to group those guys before we multiply straight across and distribute. But once we do that, we're going to distribute that x squared y to each term in the numerator and to each term in the denominator. So I distributed the x squared y squared to each term in the numerator and each term in the denominator, right? And remember, if you need to, you can write that as an x squared y squared over 1, just to really help yourself keep track of where it goes in the numerator or the denominator, okay? So now that we've done that, we can cancel out all of the denominators in our interior fractions, right? We know that all the denominators of our interior fractions will cancel out because the thing we multiplied by was the LCD of all those fractions. If for some reason your denominators don't cancel out here, reconsider what you used as your LCD, okay? So in our first fraction, we've got the x cancels out with just one of these x's. In our second fraction, the x squared will cancel out the x squared, and the y will cancel out with just one of those y's. In our first fraction in the denominator, the y squared will cancel out with the y squared. And in our second fraction, the y will cancel out with just one of those y's. Okay. So you can kind of take a look at what we're going to have left here. We're going to have a 3xy squared plus y over x squared plus x to the third, right? And just take a second to look at that while I rewrite it for us. All right, so we did all of our simplification. The first term became 3xy squared. The second term just became a y. In the denominator, our first term became an x squared, and our second term became an x to the third y. So our original equation, after we translated our negative exponents and dealt with our complex fraction, became this 3xy squared plus y over x squared plus x to the third y. Now our very last step that we're going to do is try to factor this. And once we factor, then we'll see if we can do any final simplification, and then we'll be done simplifying this expression. So when you look in the numerator, you see that both terms have a factor of y. And when you look in the denominator, you see both terms have a factor of x squared, okay? Remember, we have binomials. So unless we have a difference of squares or a sum or difference of cubes, this can't be simplified, okay? And as far as I can see, yes, we don't have a difference of squares or sum or difference of cubes. So we will just factor out the GCF of the numerator, which is that y. And we can factor out the GCF of the denominator, which is the x squared. Oops. Right. And now we look at what we've got. We don't have any common factors here. So and let me just highlight what our factors are. This whole thing right here is one factor. This whole thing right here is one factor. And then we've got two factors of x and a factor of y. So we have no common factors. So we can say we've completely simplified our fraction. And if we want to report our answer in factored form, we could report it like this. Or if we want to report our answer in unfactored form, we could report it like this. Both answers are correct. Both of these things are simplified versions that are equivalent to our original expression.